Hello everyone, welcome to this session on basic spatial analysis using QGIS as part of the online training program on Introduction to Remote Sensing and GIS using QGIS. Before we proceed, let us take a quick look back at what we have covered so far. Uh, over the last in the last week, we started with the basics of remote sensing and GIS, got familiar with the QGIS and its setup on our system. We explored various sources of open access spatial datasets and learned how to download and use them. We then worked with the delimited text data, vector data, how to georeference raster maps, data sets, scanned maps we have seen. And also we have seen how to digitize and create vector data. In the last session, we moved on to the raster data, how to download, load, visualize raster data, and how to make use of raster calculator for doing the band math and calculating of band indices. Today, now in this session, we are going to move further. We will be talking about doing spatial analysis, basic spatial analysis in QGIS. That is how we can extract meaningful information from both raster and vector data sets. We will explore vector analysis tools such as buffering and also raster based terrain analysis to identify areas to meet certain conditions. Then we will also look at zonal statistics, which is a useful technique to summarize raster values within vector boundaries or vector layers. So let us start today's session. Now we will do a simple basic spatial analysis using the vector data created by ourselves. We can prepare vector data as we have seen. We can digitize and prepare the vector data. That is one way, but we will not digitize to prepare data, but we will make use of crowdsourced vector data, that is OpenStreetMaps. Without downloading it, we will make use of a plugin, Open OSM Quick OSM plugin. Now, as you know, for downloading any plugin, you can go to this plugin option, manage, and install plugins. Now you can search here for OSM Quick OSM. You can select this. So Quick OSM downloads OSM data using an overpass API. This is a API, application programming interface, which will fetch data from the OSM, and then you can add um, it executes custom overpass queries in QGIS to get the OSM data. This has so many downloads, and so this is the rating. So let me install this plugin. Be aware that while installing the plugin, you need to be connected to internet, because it is fetching the data from the repository. Otherwise, while working on QGIS, you don't require connectivity. So let me, after installation, Quick OSM has been installed. You can check it by going to the vector menu, and you will find a new option of Quick OSM has been included. And so you can click this Quick OSM, which will open a new it is asking it is open it has opened a new dialog box which says OpenStreetMap is open data, licensed under Open Data Commons database license by this OpenStreetMap Foundation. It requires that you use credit on any product using OSM data. You should read this. So you can select this option of I understand the copyrights and access the plugin. So this is the plugin window. Now what we will do is we will fetch data from OSM and we will prepare vector data for our area of interest, and then we will make use of that data for doing some small analysis. I am following the QGIS training manual. They have done the exercise for some region in South Africa. I will be doing the same exercise. I will try to do the same exercise for Pune region. Now let us look at it. Now, suppose you want to answer the this question. You are a real estate agent and you are looking for a residential property in Pune metropolitan region for clients who have this following criteria. Some criteria for which you have to do the vector analysis, and for some criteria you have to make use of raster datasets and do the raster analysis. So, first of all, the residential the property should be located within the Pune metropolitan area that we have defined. We will define the extent of the area, and it must be within a reasonable driving distance of school, say less than 1 kilometer. It must be more than 100 meters in square meters in size, the area of the building, and it must be closer than 50 meters to a main road and closer than 500 meters to a restaurant, and it is south facing, say, with a slope of less than 5 degrees, and in case the slope is less than 2 degrees, then aspect doesn't matter. That is how, in which direction it is facing, it doesn't matter. So these are all the criteria that we have with us. Maybe there may not be. We are taking this from an example from the exercise manual, training manual, but there may be not be any location at all when we take the building data and all those data sets from OSM, main road and restaurant and school data, as well as we will take the DEM and calculate the slope and aspect. We may not get the ultimate result, but the idea is to learn how to do spatial analysis using such criteria, multi-criteria. So let us try to fetch the data. Launch your QGIS and open a new project. Now we will be fetching the data of buildings, highways, schools, and restaurants from OpenStreetMap server, data server, or pass server using QuickOSM plugin for an area of interest. Your area of interest is Pune metropolitan area. If you have a shapefile of Pune metropolitan area or any other area of interest, you can use the layer extent. Otherwise, you can make use of a base map and then choose your area of interest. So you can go to web. You have already installed Quick Map Services plugin and configured it. So you can add OpenStreetMap's OSM standard as a base map. Then on the extreme left corner, you have this status bar from where you can search processing algorithms and also locations and other things as listed here. Among the list, you will find one option of Normatim geocoder. You can double click it after selection and then type Pune. So you can see two such results have come. One is Pune district and another is Pune data. You can Pune city. You can double click on your result. So this is an extent of Pune district, And second option, if I double click Pune, so this is the extent of Pune city. So I can take this as Pune city and surrounding, this as the area of my metropolitan region for my current for the current purpose of analysis. So then launch your quick OSM plugin. Here in OSM, the data are saved as key value pairs. To know the key and value pairs, you can click this help with key value. So this is a portal regarding quick OSM plugin. So quick OSM is a QGIS plugin to download data from Overpass server. And if you want to get help from regarding the OSM keys and values, you can click here on this link, or you can directly search and open wiki OpenStreet map. So go to this URL wiki.openstreetmap.org, and here you will find an option of uh, browse the map feature documentation. You click here, and here you will find all the features, listing of features in key value pairs. If you want to find out, so you can see, you can read, OpenStreetMap represents physical features on the ground using the tags attached to basic structures. Each tag describes a geographic attribute being shown by that specific node via relation. So here you search for buildings, say, yeah, if you see building, it is the name of the key with these values: apartments, barracks, bungalow, cabin. These are the different types of buildings. So if you want to gather all the building layer, you can specify the value key as building without specifying the value. Then it will fetch all the buildings data. Let us try it. Go to quick OSM. You can type building, then it will auto suggest the key name. Select the building and don't put any value here. And then where you for which region you want to get the data for your canvas extent. If you had layer, you could have choose layer extent. And under advanced options, now buildings in here are saved as polygons. So you can uncheck points, lines, multi-line strings, and keep the multi-polygons checked. You can increase this timeout because buildings and highways, especially these two layers in OSM data, they are voluminous, or the number of features is very high. Therefore, it may take time. So you can sometimes, if it doesn't fetch in time, you can increase this timeout. You can try, you can do trial with this 25, and then if it doesn't, then you can increase the timeout value. So click on this run query. Now you can see it is parsing and it is fetching the data from pass server. So it will take some time to run. Wait for it. Once the query is successfully run, you will find this message: successful query, one layer has been loaded. You can check your map canvas area that a layer of buildings, temporary layer of building is added. You can check that this consists of numerous building features for that canvas extent. You can zoom to the layer back. Now we will similarly fetch the data of highways by going to vectors, quick OSM plugin, and the key, as you have seen, you can check, you can type highway, and without giving any value for the same canvas extent, you can run the query after unchecking points, multi-polygons. This time your features are either lines or multi-line strings. So run the query. Again, it is downloading data from overpass. Wait for it. Just like buildings, highways is also a very dense feature network will be there. Yeah, it has also successfully completed, and the layer has been loaded. Highways, you can check. It has arterial roads as well as state highways and other local, even residential colonies. If the highway has been marked by some user, you will find. If a road has been marked, you will find it here. So now I will fetch data for the same canvas extent. Just in case, if you zoom out, highways, you will find it is are zoom to the extent, zoom to layer, right click and zoom to layer. It will give you a larger extent. Why? Because the highway features are continuous and they are going out of the canvas extent. You can come back to the original extent by clicking the buildings, right click on building layer and click on zoom to layer. Now we will quickly fetch the remaining data, that is key of amenity and school. You can even check the values from this drop down menu, which has many values. Let me choose school, then choose the canvas extent, and here now we have some of the schools maybe also be mapped as polygons if it is a larger area. Otherwise they are points, so they are saved as points. So you can check points and run query. Similarly, you run the query for amenity and restaurant. These two will not take much time. Run the query again. Now close. Now you have got all the 4 layers. You can check, these are restaurants and these are schools. So we have got 4 temporary layers, temporary scratch layers only, and if you don't save them, they will be discarded on closing the project. So what we will do is we will save them by right clicking and then this option of export save features. As another way of saving the temporary layers is you go to this icon of temporary layer and then click on that icon. It will open a save scratch layer option, and now we will be saving these 4 layers as geo package. In a geo package we will be saving them as separate layers. Now you can see buildings is polygon layer, highways is line layer, whereas restaurants and schools are point layers. So I will be choosing the format as geo package. Create a folder, exercise data session name, session number, and then say training data, training vector data. Okay, extension gpkg, then give the layer name highway, and then click OK, save. You see it has been saved. Now similarly you can save all these. Now I will be using export save features as geo package. Now browse to our GeoPackage training vector data. You may notice that I am not giving any namespaces in the name of my folders. Okay. Always use underscore whenever you want to use a separator, word separator. Then restaurant. Geometry type you can choose as point and then click OK. Similarly, school, right click, export, save feature as GeoPackage. Choose the same GeoPackage and choose the layer name as school and then geometry point. OK. And finally, building, right click, export, save feature as GeoPackage. Choose the same GeoPackage. Building layer, layer name as building and geometry type polygon. Click OK. Uh, there is some issue of saving building layer. Export to vector file failed. Error creation of field fuel petrol Q failed. A field name with the same name already exists. You can try saving it as a shapefile, otherwise save feature as SRE shapefile. In the same folder I will be saving it as building. Geometry type polygon. Click OK. There is some issue with fields. There are so many field names. I have checked, there is an issue when we are saving the buildings layer. Say, you can see the error message also. Training data and give the name as building. Now it has so many fields. If you see OSM featured data, so many fields are there, and if I am trying to save, it is giving me a error regarding creation of some of the fields. So what we can do is we can leave out, you can check the attribute table. You can keep this full ID, OSM type building, and all these fields are not required. We can remove them, and then towards the end we have office name, and these fields we can keep. So let us try. Let us save them as shapefiles instead of save them all of them as shapefiles. So export save features as shapefile building and deselect all fields and select these, and then some fields here, at least name of office, name, these things. Name of the building, minimal number of fields we have selected, and then you can click on OK. Yeah, now it is saving. There is some issue with saving of some of the fields. Maybe the length of the fields, length of the name of the fields, or number of fields, something is creating an issue. So I will save the remaining layers quickly. This is, I will go to the same folder and save them as restaurant shapefile. Only in case of building I have made that change, selected features. Then highway, where is my building layer? It is saved somewhere else. Highway, then school, save feature as, and then school in the same folder. Okay. Yeah, building I will save it again, the temporary layer. Export, save feature as, go to the folder, give the name building, save, and let me try saving without any. Yeah, it is still giving me the error. So what I will do, right click, export, save feature as, select building, empty shapefile has been created, save, and then you deselect all these fields and select only few initial fields and last few other fields including name, right, and then click on OK. Alright, yeah, it is saving. So now we have prepared our training data of 4 vector layers. You can check the folder where we have created our data. You have these 4 shape files. You could have also saved them in geo package after removing those some of those fields of building which are creating an issue. Now I will remove these temporary layers. You can also look for other OSM data, though it will not be required for this particular analysis, spatial analysis problem. But if you, it has lot of data which will be useful for, you can create your, if you have no data of your own area of interest, you can make use of OSM data. You can using quick OSM plugin, you can fetch data related to many features like mountains, hills, lakes, reservoirs, waterways, rivers, etc. Say for example, if I want waterways, you can check in the that key value page, rivers, you will find it with a key waterway and value. You can check canal, dam, river, you can select river, select the canvas extent. Again, it will be lines or multi-lines. Run the query, and then the data is fetched. You can check the data, uncheck everything else. It is not visible, so I will remove my base map also. So you can check that these are the rivers. Uh, Let me change the symbology. I will make it blue, and then I will increase the stroke width so that it will appear prominently, and then I will put on my base map. You can check, see, this is Kadakwasla reservoir and this is Mota river, right? This is Mula Mota confluence, this is Pravara, and these are other rivers. So anyway, in this way you can it is a demonstration of how you can fetch data from OSM using Quick OSM plugin. So once you created your vector data and saved them as shapefile, now all these layers, if you can check the properties, they are in CRS of GCS, that is Global Coordinate System. Now we are going to measure distances in meter for our spatial analysis. Uh, so degrees will not be convenient to work with. We have to go for a projected system. We have learned about UTM projection earlier. So this particular region of Pune falls in 43 north, 43 northern hemisphere zone. So I need to project. What I will do, I will project all these four building, highway, restaurant, and school layers to this UTM projection. Now for that I need to know the EPSG code, and we know where to look for. I don't require water way. I will remove it. So you go to spatial reference .org and you search for, and how to know the UTM zone, that is you can also check that UTM zones of India. So these are the UTM zones of India. Yeah. So if you are working in somewhere in Saurashtra, you have to, or Kutch, you have to select 42 zone. And in Maharashtra, most of the region, Pune region also, it falls under 43 zone. Say in UP or Andhra Pradesh, you will go for 44 zone. For say Bihar or West Bengal, you go for 45 zone. Assam or Arunachal, you go for 46 zone. Yeah. So our zone is 43. You can search for the UPSG code UTM43N. Among the results, see, you will find WGS84 is our datum. These are the other datums, as you can see, maybe the old datums. Then UTM zone 43 north, the code is 32643, EPSG 32643. So yeah, come back, then you go to processing toolbox, then check for reproject. Yeah, under vector general you will find this tool of reproject layer. Click it. Now you select your input layer, building, say target CRS is 32643. You have to select. You can go to this select CRS icon here. Then click this, and then you type your code 32643. And if you have recently used, it will be coming here. Otherwise, uh, you can go to predefined CRS and you will find this WGS 84 UTM zone. You can select it and then go back. Now the target CRS has been specified as EPSG 32643, and then you run. It will be saved as a temporary layer, no issue. You run it. Close. Now this is the reprojected building layer. You can hover your mouse on it. You can see that its EPSG code is 32643. That means it has been reprojected. You can check the properties, go to information. The CRS is EPSG 32643. You do the same process for other layers. Now you can check it here itself. It is there 32643. Now if you run, it may create number of temporary layers. It may lead to confusion. So let us save as save to file. In the same folder, restaurant you give a name of restaurant underscore reprojected. Then run. Similarly, you can go for highway, reproject layer, change the target CRS and save to file highway underscore reprojected. You do it for buildings which you have just created a temporary layer. You can make it permanent. You have this option of make permanent. Click that, and here you can give the name buildings reprojected. It has already been projected, so save it. You can do it even for school. This is taking some time. Let it run. Reprojection of highway layer. Yeah, it is done. Then finally school target CRS 32643 and save to file. Give the name reprojected layer, save to file, school underscore reprojected. Save and run. Now you have got all the 4 layers, and also reprojected. This one was made permanent. This actually you can you have saved it as building reprojected. Let us add it. Yeah, and remove the other layers. You have 4 reprojected layers. Now we will be doing the buffering of layers. Now we will create buffers for school, highway and restaurant layers to find areas fulfilling the conditions. What were the conditions? That it must be within a reasonable driving distance of a school, say 1 kilometer, and it must be closer than 50 meters to a main road. Actually, in our case, what we have done is we haven't filtered the highways, we have taken all the highways. When you do the analysis, you can filter by giving values of highways. Give the key highway and then select one or two values and then fetch the data. Then it will be doable. Otherwise, in our case, we have a very dense network. Anyway, the purpose is only demonstration of how to do buffer analysis and then also raster analysis also we will see. And then 500 meters from a restaurant. Let us create buffers. So first you go to school reprojected, which is in UTM zone. So you can give the buffer distance in meters that we are working in SI units. So go to processing toolbox and search for buffer tool. We will find it in the vector geometry. Double click it and you give the input layer as school reprojected and make sure that the units of distance are in meters, and then you provide 1 kilometer, that is 1000 meters, and then you can also select this option of dissolve result so that all the buffers will be dissolved together, and then you can save it to file and give the name school buffer and run. So once it is done, you can check the school buffer layer. So for every, and you can bring the schools layer on the top of the school buffer. Now these dots are the green dots are the schools, and you have created buffer of 1 kilometer around every school. That is why they are in their buffer zones are in circular in shape. For point zones, buffers will be in circular in shape. Then you have dissolved the layers. So there are no internal boundaries. So our areas of interest will be lying within these buffer zones, and also they should intersect with the buffers of other highway and restaurant buffers. Now let us quickly do the buffering of restaurants. Same procedure. You select the input layer as restaurant reprojected and give the distance now as 500 meters and dissolve the result and save it as restaurant buffer. Run it. So you can check. Yeah, these are restaurant buffer. Then similarly, highways, you can select only main roads. Even now you can do that by going to attribute table, but there are too many features about a few. See, you can check there are about 83,386 features, but here you can check because the layer is very big, features are very numerous, it is a bit difficult, it is not responding to handle this. But you can see what are the types of highways that you have in the category of highways. You can see busway, all these things we can remove. living street also you can remove. You can keep prime residential also you can remove. You can only select primary, maybe primary, secondary, service, tertiary, trunk. You can even leave out unclassified. Anyway, I am not doing that. You can do that. We will quickly create a buffer for highways. So again, you launch the buffer, and this time you give highway reprojected as the input layer, and now you have to give 50 meters buffer and save it as highway buffer. Now this will take time because we have thousands of features. Run it. And then what we will do is we will take the intersection of school, highway and restaurant buffer to find out the areas which are fulfilling these three conditions. And then we will see which are all the buildings which are in this area, intersection area. And also there is one more condition, the building should have real estate space, or the building should have area of at least 100 square meters. So you can filter your buildings data also. Otherwise, again, buildings data has hundreds of features, thousands of features. It will be very difficult to handle. So wait for this buffering to complete. Now once the highway buffer is also completed, you can see it has taken each and every road and created a buffer of 50 meters, a strip, because it is a line feature. So every line you see, every highway will have such a strip. Now we will run the intersection tool. Again, go to processing toolbox. The processing, as we have said, it is the heart of QGIS. You will find all the algorithms here, and it may so happen sometimes you will not find processing in the main menu. What to do in such a case? Now, if you go to, we learnt about plugins. We had just touched upon plugins. Now this processing is actually a core plugin, and you cannot uninstall it. In case if this is not checked, then you will not find processing here. So when you don't see processing in the main menu, you can go to plugin manager and then check processing. So let us run intersection. Now in intersection also you have two types of tools. One is under you will find these tools under vector overlay. Simple intersection of two layers, and then if there are multiple layers, like in our case there are 3 layers, you will run intersection multiple. Now double click this tool, and here you have to provide the input, say school buffer, and other overlay layers. You can select the highway buffer and restaurant buffer and go back after selecting the overlay layers, and you can create a temporary layer for now because we are not going to do the entire analysis here, and you can run. Again, it will take some time because your highway buffer has many features. Now once the intersection is completed, the algorithm is finished, close it, close the dialog box and go to this temporary layer of intersection. Yeah, you can see. Let me also keep the restaurant buffer and school buffer on. Yes. So you can see the intersection of all these three buffers. It is marked in red. Okay. So now you have to see which all our buildings are coming in this zone. You can bring the buildings layer on the top, and we have to do the filtering of building. So let me uncheck everything else other than building reprojected and intersection. In fact, this intersection area you can dissolve it to have a to remove the internal boundaries. Let us see if we can do that. Dissolve, yeah, vector geometry dissolve. Run this with input layer as intersection, and let us create a temporary layer. Anyway, we are not, we are only demonstrating. So you have this dissolved layer. Yeah. Now go to buildings reprojected. Now we will be filtering, we will be calculating area of each building, because I don't think we have area as a field in the buildings layer. So how to modify any layer? You have to go to this toggle editing mode, right click and open the attribute table, and then go to the toggle editing mode. Once you go to, click on this toggle editing mode, many of the other options are now activated. Yeah, so you can check these. Delete field, new field. You click on this icon, new field. If you take your mouse onto the icon, it will tell what it does. So we are going to create a new field, and then we will name it as area. And then, yeah, it has to be a decimal. Then click OK. So you will find a new field area is created with without any values. We have to populate these values. Now to calculate area, you can do from field calculator. Again, you will find this option, open field calculator. Click it, and in the open field calculator, we are not going to create a new field. We have already created a field. We will update the existing field, which is area, and then you will find function to calculate area of polygons. Under this geometry option, there is one function with dollar symbol area, which returns area of the current feature. So what we can do, you can double click this so that it comes in the expression, and you can see the preview, the area in square meters, because we are working in UTM zone. So apply it. We are updating the field area. Click on apply and OK. Now because there are thousands of features, again it will take some time to calculate the area and load. It is done. Once it is done, you can close this and check your area column. So you can see there are features with area greater than 100 square meters, and also there will be some features with area less than, like individual houses may be having less than 100 square meters. So here you can filter out. How do you filter? You can sort by clicking on column header and then check the largest value and the smallest value. The smallest value, as you can see, 11.736, and you can filter out all these, and the largest value is 7261.522. Anyway, how do we filter? You can do this from select by value option. Let us come out of this. You come out of editing tool. Now we have created a new field area. Save the layer, come out of toggle editing mode, and let us go to our map canvas area. You will have this option here. Here you will find one option of select features by value. After selecting your buildings reprojected layer in the layers panel, you click this select features by value, and you know your field name is area. So you can specify area greater than 100, and you click on select features. Now only those features, most of them have area greater than 100 square meters, only those features are selected, and you can see there whenever a feature is selected from a vector layer, it will be highlighted in yellow color in the map canvas map canvas region, and if you open the attribute table, they will be highlighted in blue. The rows, individual rows will be, you can see in the attribute table. These are all least area is 0.689. Yeah, now if you see, yeah, when the area is above 100, all those features are highlighted, are selected. Now what you can do, you can right click and export. Now save selected features as. Now you create a new layer with of buildings with area greater than 100 square meter. And finally what you need to do is you have to overlay the newly created buildings, filtered buildings layer on your intersection, this dissolved intersection, and see which are all buildings which are intersecting. You have to run again one another tool, intersection, and the vector overlay, and you have to give your input as your buildings layer after filtering by area, and overlay layer as dissolved, and then you run and save a new layer which is the end result of your vector analysis. You have two more conditions to be fulfilled, that is slope and aspect, that we will do using raster analysis. Now after conducting the vector analysis and identifying the buildings which are suiting your criteria, that is whose area is greater than 100 square meters and whose distance from the schools, the restaurants and roadways is less than the given stated conditions in the criteria. Now you will have to check whether the other conditions on related to slope and aspect are also fulfilling. For that you have to conduct the raster analysis, raster terrain analysis using the DEM tile. You will basically you will see those filtered buildings or residential properties and see whether they are located in those regions where the slope is less than 5 degrees and aspect is south facing, or if the slope is less than 2 degree, the aspect need not be considered. That is the problem statement. So let us first load our DEM tile. We had downloaded the DEM tile and used it in the previous session from CGIAR CSI Geo portal. I will add the same tile, and to check whether it fits, it is occupying or it is extending up to your area of interest, you can add a base map from web quick map services and then select OSM standard. Now you will see, you can check whether it covers the Pune metropolitan region. It is covering, so you can make use of this DEM tile for further raster terrain analysis. This DEM tile is in EPSG 4326 projection. CRS is global coordinate system. You can get to know about it by quickly hovering your mouse over the layer, or by double clicking and going to the properties. Under information you will find it, layer properties, you will find this. So we have to project it to the UTM coordinate, UTM projected UTM zone 43 north. For that you have this option under raster menu. You have the option of projections and warp project. You click on warp reproject and you click the input area is your SRTM original tile with in the global coordinate system. The source CRS, you can check here, it will be already be there, which is same as the project CRS, but still if you go and click this symbol of select CRS, and then if you select the option of predefined CRS, you can search by the code 4326, which is the source CRS. It is the global coordinate system. So you can check this and go back, and then target CRS, the CRS, the projected coordinate system which you intend to reproject this layer to, which is UTM 43N, that we have seen it. The EPSG code is 32643. You can click again on this select CRS and then go to the predefined CRS and then search for 32643 and select under the projected coordinate system. Go back and you keep the resampling method as it is, the nearest neighbor, and you can save the reprojected layer or keep it as an intermediate layer, temporary layer. Ultimately you want to calculate the slope and aspect, so you run it. So you have this reprojected layer. You can hover the mouse or check its layer properties to see the CRS, which is 32643, which is the projected coordinate universal transverse Mercator system. Now we will calculate the slope by using processing toolbox. The options under processing toolbox, you search for slope, which you will find under raster terrain analysis group of tools. You have to provide your input elevation layer, which is reprojected layer, which is a temporary layer in EPSG 32643, and you keep the other options. You can save it to your disk as slope, or you can run it, which will create a temporary layer. You can save it afterwards. You can run this, so you can check that slope layer has been created. Most of the areas are, you can check the identify feature button and check the values. Most of the region is gently sloped. However, near the divide, western divide, where this Western Ghats ridge line, the slope is as high as 50 degrees. So this is one thing, and then we will calculate the aspect. For that you will again go to processing check the toolbox and then aspect. You click on aspect tool under raster terrain analysis. Again you give the elevation layer as reprojected and then run this, which will calculate the aspect whose value will vary from 0 to 360 degrees depending upon the face, the direction in which it is facing. So you can see the values, check the values in degrees, which vary from 0 to 360. Now in the problem statement you have to identify the areas which are facing south. So for that you can make use of aspect as the input layer to calculate to filter the areas which are facing south, where aspect is greater than or equal to 90 or less than or equal to 270 are the are the pixels where the aspect ranges between 90 to 270 face the southern direction. So we can implement it using raster calculator. You can go to processing we toolbox and then search for raster calculator as we had used it earlier. You will find it under raster analysis. You click on raster calculator and then you write the expression by double clicking on aspect. So aspect should be greater than or equal to 90 and it should be less than or equal to 270, which will fit our criteria. So this expression, if it is valid, then you will find this green expression in green color expression is valid, and then you can run this. Before running, you can give a reference layer for automated extend cell size and CRS. You can select the aspect layer itself and then you run this, which will create a Boolean layer wherever the expression is valid and aspect is between 90 to 270. It will give a value of 1, otherwise the value will be 0. No data values will be treated as no data. I think no data values are there where there are water bodies. Like if you see in the aspect, here you have no data value in the sea, and also inland water bodies you will find, because they are flat. Anyway, we will see that. So in the output you see the output varies from 0 to 1. Either it is 1 or 0. Now we are interested in considering the values of pixels where the value is 1. Now to check whether you can, with identify features, you can check only the values of an active layer one at a time, right? You can either check the output or you can either check the aspect. If you want to check the values of all the raster layers which are there, you can make use of one plugin, useful plugin. You can download it by searching for value tool. Okay. I had already had a look at it. Value tool, which is a QGIS plugin to display in table or plot values from raster layers at the current mouse position. You can install this plugin. Once you install this plugin, you will find a panel of value tool getting visible here, and then you can select a few output and aspect rasters active, keep them active, and then you can scroll your mouse anywhere where you will find the values of output and aspect changing as you scroll the mouse, and wherever the value is less than 90, as the output should be 0, and if it is greater than 90 it will be, and less than 270 it should be 1. So I think our Boolean layer is fine. So you can cross this value tool And similarly, you can create a Boolean layer using slope by raster calculator. You can generate one layer, one Boolean layer where slope is less than or equal to 5 degrees. It should point out to 1, and where it is greater than 5, it should be 0. Similarly, you can calculate where the slope is less than or equal to 2, it should be 1, and when it is greater than 2 degrees, it should be 0. Now you put all these three conditions where this aspect is 1, the southern facing, and where slope less than or equal to 5 degrees is 1, or wherever slope is less than or equal to 2 degrees, then you need not consider the aspect. You again implement a expression in the raster calculator by writing an expression, and then you will get finally uh, areas or the pixels where the slope is less than or equal to 2, or where the slope is between 2 to 5 and it is southern facing. You will find those the pixel values in the form of raster. Now, to combine the analysis, the raster analysis as well as the vector analysis, you have to convert your raster layer into the final raster suitability raster. You can name it as suitability area raster layer, and you can convert it into a vector where the values, wherever the values of 1 are there in the raster, they will be in the vector. It will be suitable value polygons will be created. If it is contiguous area, a bigger polygon will be created. In fact, you can do the sieve analysis also, but I am skipping all those things because we are short on time. So once you have the suitable pixels from raster analysis, you can convert it into a vector by the option of raster conversion polygonize from raster to vector, and then you fit the buildings which are intersecting this newly created uh, polygonized raster to find the final set of buildings or residential properties which suit both the criteria, in all the criteria. In this way, you can do the spatial analysis to identify regions which fit multi criteria, which can be easily done in using any GIS application, making use of raster calculator and making use of expression in vector analysis. There are many tools like buffer. That is for this session on basic spatial analysis. Now we will do one example of zonal statistics. Zonal statistics is a powerful spatial analysis technique which integrates raster data and vector data to derive meaningful statistics. Like if you want to calculate some statistical value of raster data sets such as mean, median, minimum, standard deviation within your administrative or hydrological boundary, you can use zonal statistics. It will be very useful for understanding how any hydrological parameter or continuous variable such as elevation or rainfall or even NDVI. Now in the previous session we have seen how to make use of NDWI to calculate the to map the water bodies. Similarly, we can use MNDWI for which is a better index of mapping the water body. And then once you have your vector layer, and if you want to sum up the water pixel area, for that purpose also you can use the zonal statistics. So let us try to calculate average elevation of each district of Maharashtra, say. For that we will take our input layers of SRTM 90-meter data set, void field data set, and then we need to have the administrative regions. We have seen how we can download district boundaries shapefile from the India Varis portal, which we have made use of. We will be using that. And for SRTM, we have one tile which we had already downloaded, but I think that will not cover the whole extent of Maharashtra. You need to download more tiles and then merge them. So the existing tile is this much, whereas you can add your base map and see the extent of Maharashtra. You will require more tiles. So let us download first our SRTM tiles quickly by going to the website srtm.csi.cgir. This doesn't require any login. So we already had this tile, then we need this one, maybe this one. We have to check search. So we have this 5109 tile, so we can download this one, and also we will require some portion of this tile and maybe this tile also. Let us download these 3 additional tiles. And this portion I am not sure, but let us download. Even if we have larger mosaic, it doesn't matter. So I have downloaded 4 additional tiles of SRTM. Now let us try to add them to our layers panel by simply drag and drop these zip files. Yeah, I think we are covering the whole of Maharashtra. You can check and uncheck the layers to see whether you need all of them or not. I think yes. Okay, now we have to create a mosaic. For that you can go to raster, then miscellaneous, then merge. Now all these SRTM tiles are in GCS. You can also see the project CRS is 4326. Go to raster, miscellaneous, merge. You can also use this option of build virtual raster. Let us say we will merge these input layers, all the 5 SRTM. You select them input layers, and go back. So 5 inputs are selected. How to select? You go to these 3 dots, then all the layers which are in the canvas you can select except the Google Road, and go back. Then you have to give some you have to fill these values. Say, let us check the metadata of these tiles, SRTM tiles. What is the no data value? The CRS is anyway it is going to be same. Pixel size 0.000833, that means it is 90 meter. Yeah, no data value is minus 32768. You can specify that. So input pixel value to treat as no data minus 32768, and assign specified no data value to output. That also you can give the same value. So whatever new tile which you are creating, it will have the same no data value. We touched upon no data value earlier. No data value is a very high negative value which is specified in the metadata of the data set. So whenever you have no data value, it will not be considered in the analysis. It will be masked out. So when you are specifying that this is my no data value, whenever a pixel has that value, those pixels will not be considered for the your analysis. Because in DEM there will be many no data value, because it is a derived data. Acquisition errors will be there. So yeah, sorry, 32768. And then you can save, you can, if you want, you can save it merged, DM merged, or you can keep a temporary file. Now if you see, if you are trying to save, it is getting saved as SDAT file. This is another format of saving your raster files. Anyway, I will run and I will create a temporary layer. There is some issue. Oh, .zip is not recognized as a file format. Recognized. So what we will do is, we will extract all our layers. Say, let us copy them first. Let us create a new folder on zonal statistics. Five tiles. Because these are already loaded, you cannot transfer them. Let me close the project and then try again. Yeah, and then you can add your raster layers. No, before you have to unzip them. Go to zonal statistics. Don't keep namespaces in the folder name. Yeah, you extract all these zip files. These are processed layers, so there are many auxiliary files. These are voidless SRTM tiles. 1, 2, 3, 4. Okay. Now let us add all the raster layers. you have to add the .tif file, the main file. Add it twice. Now you go to raster, miscellaneous, merge, select the input layers, give your input no data, output no data, run. Once it is done, you will get this message, algorithm merge finished. You close this dialog box and you can check the merged layer, which is a temporary layer. You can uncheck all the other layers and zoom to the extent of merged layer. So you will find that those artificial like boundary like things, lines in between the tiles, because of visualization effect, because every tile is by default it is displaying its default visualization within the range of the values. So even though the values at the boundary are same, there is no change as such, but visualization effect is there, so you will find these. Now once you merge them, you will not find. Now the range has increased, the range of values. Now what we will do, we will bring our district shapefile which we had downloaded from our India Varis website. Copy this to the same folder and then extract. Yeah, and you add the layer. Now this time you have to go for vector. Add the shapefile. Okay, so bring it onto the top. Okay, so now you have to first filter the districts of Maharashtra from this shapefile. That can be easily done using selection. One crude way is opening the attribute table. You sort your state code and go to the code of Maharashtra and select all the districts. Another, but you should know what is the code of Maharashtra in the first place. Yeah, it is MH. So you can select in this manner. But the more sophisticated, better way or sophisticated way is by selecting by value. You can go to this select values, features by value, after highlighting this district layer, and then in the state code you check equal to and give the value MH. So we had already selected from the attribute table, that's why these districts are selected here. You unselect them and then you do this select features by value and is equal to, state is equal to, the code is MH. And then click on select features. Now you can see all the districts of Maharashtra are selected. Now what you can do, you can right click, export, save selected features as, and save it as a new shapefile in the folder as Maharashtra districts. Now it will have the original CRS, that is LCC. You can check by going to properties, right click, properties, information, WGS 1984 Lambert conformer conic. Okay. And your merged layer is having the original CRS of the SRTM, which is 4326 WGS 84. Okay. Now the next step is we no longer require these SRTM individual tiles as well as the whole districts file. You can remove them from the layers panel. Oh, you need one more tile of SRTM. So let us go back to this portion. Okay. This such. No, not even this. Just a minute. I think we have to download this tile also. Let us check. $5309. No, we haven't downloaded. So extract it. Yes. And then drag and drop to QGIS layer. Yes. And then you have to create a new merge layer. In fact, you require another tile. This one. This one. $5308. Download. Anyway, you are going to get the user exercise data. You can directly load all the input layers. Extract. Yes. Now I have to merge this temporary layer with these two SRTM to create a new layer of merged. So for that I will go to raster, miscellaneous, merge, input layers, these three, go back and select -7 32768, input no data value 768, and then run. Once it is complete, you will get a new merge layer. You can uncheck the remaining ones, including this temporary. Yeah, I will remove these three layers. Yes. Yeah. Now to perform zonal statistics, both the vector and raster layer should be in the same projection. So what you can do is you can reproject your district shapefile to let us reproject both these layers, raster as well as the vector file, to UTM. Um, Actually, this UTM zone is spread over. There are two zones, but anyway, let us try by only reprojecting this district's shapefile by going to processing toolbox, reproject, input layer, no, what I have chosen, yeah, you have to select reproject layer under vector general, yeah, Maharashtra districts, target CRS is 4326 WGS 84, okay, and then run. It is done. Now you have it in the global coordinate system. Now you can look for zonal statistics in the processing toolbox, which you will find under raster analysis. Double click it. Now here your input layer, that is the raster layer, is reprojected temporary layer. You could have saved these intermediate layers also, and then raster layer is your merged, and there is only one band in raster. In case if it is a multispectral imagery, you can select a particular band also. There is only one elevation value, and then output column prefix, fine. Now what it does is it calculates statistics of the raster layer for each feature of the overlapping polygon vector layer. So what all statistics that you want to calculate? Elevation, there is no meaning of count. Count is useful when you want to count the number of pixels. Say if there is a binary layer or a boolean layer 1 and 0, like in case of water and no water, if you want to count the number of water pixels, we can use this, and then you can multiply the number of pixels with the pixel area to get the water spread area. Here you can have no sum is also has no meaning. Mean elevation, yes, what is the average elevation area of each district, that will be interesting. What is the maximum, what is the minimum, right? Minimum area, standard deviation also you can take. So let us have these three: mean, median, minimum and maximum. Then go back, yeah, and then what will be the output, how it will be saved? it will be saved as a shapefile. Okay. So let us try to run without saving. A temporary layer will be created. So what it will do is it will fetch the attribute table of your districts, and it will add new fields, sum, maximum and minimum. So you see a new layer of zonal statistics is created. It is a vector layer. You can right click and click on open attribute table. Now earlier attribute table, if you have seen the districts, it is up to the this length. Now there are three new fields which are added: mean elevation, minimum elevation and maximum elevation, right? Um, so it depends upon your input layer. So you can check the mean elevation of say Pune district is about 657 meters, which seems to be reasonable, and the minimum elevation is 100 meters, as the some parts of Pune district they spread across the western divide, even though the Pune boundary, western boundary is along the western Ghats water divide, but some Konkan region is also there. So you have minimum value 100 and maximum value is 1419. Again, it is reasonable. Now one more time, this the actual values, it depends upon how good is your DEM. This DEM is 90 meter DEM. Um, so I think they are very reasonable. You can even check the any other known district. Mumbai suburban mean elevation is only 29 meters. Now you see there are some abnormal values. These are these may be some acquisition errors, minimum values. So that is why you always try to when you do the visualization, you spread your values between +2 to +98. You leave out the outliers. Yeah. Satara district is the district with the highest mean elevation, and Mumbai suburban is the district with the lowest elevation, and the maximum elevation you see it is in Nashik district. Minimum, I don't think it is not a proper value. So in this way, whatever be your raster layer, be it rainfall map, be it say population density map, or be it elevation map, be it NDVI, you can calculate average NDVI for any polygon, for command area or for district or taluka or hydrological boundaries like basin, sub-basin or watershed. You need to have the polygon layer with you. So in this way, you can make use of zonal statistics for integrating raster and vector data for deriving meaningful statistics. And you can save it as a layer, and you can save your table, copy the table and attribute table and create a CSV file. And before closing, some of you were asking about how to prepare contour maps. Now the contour maps can be easily prepared using in GIS by a click of a button. The thing is, again, they will not be very accurate. If it is planar area, you will get almost you will get straight lines because it depends on the accuracy of your DEM. Now we will try to create contours for Pune district. Now how to do that? First step is you have to first select your Maharashtra districts file, and then click the select features by area and click inside Pune district. Then it will be highlighted as selected. Now you can right click and save export save selected features as, and then you can give the file name as Pune district. Say you are saving to the disk, and then run. Then a new layer is created. Now I don't require this Maharashtra zonal statistics reprojected. I am removing all of them. I will only keep my merged SRTM and Pune. Now I don't require the whole region. I just want to tell you one more functionality of clipping. What I can do is I can clip my elevation layer to my up to my area of interest, that is Pune district. So for that you have an option under main menu of raster extraction. You will have this option of click raster by mask layer. So your input layer you can give it as merged and mask layer as Pune, and source CRS your input layer is in GCS, that is EPSG4326, and target layer also you will keep it same. Okay, and then I will not do anything else. I will run it. A temporary layer is created, clipped. So you can check now the temporary layer of Pune. You can right click and zoom to the extent. This is Pune elevation map. You can change the symbology as we have done earlier. I will quickly do that. There are some regions, if you see, you can make use of this identify features. Some regions which are of low elevation, less than 200 meters, but then there is this divide. The western boundary, actually it follows the western divide, and then there is a gently sloping land towards the east. The highest point is about 1300 or 1400. So you can check these portions. Average elevation is around 600 plus. So anyway, let us move forward. We have this clipped and I don't require this merged layer. I will uncheck. Now yeah, I was doing the symbology. I will go to properties, symbology. I will go, instead of single band gray, I will select the single band pseudo color, and in the color ramp I will select a user defined color ramp, create new color ramp, catalog city. Okay, I think we have covered this. Under topography there is, you have this classify, apply. Okay, so you see now you can get an idea where highest elevation is in this portion, 1300 plus southern boundary. Okay, now you have this Pune elevation map. Now we want contours. For contours you can go to processing, go to toolbox, and then here search for contour. You will find the tool of contour under raster extraction under GDAL. You can double click it, and here you have to provide your input, which is clipped layer of SRTM, and you can decide the contour interval. If you give a smaller value here, then you will get a very dense network of contours, and it may also take some time. What we will do is, because the elevation is varying from 100 to 1400, let us have an interval of 100 meters, and then let us do not save. We will run temporary layer. It is done very quickly. It is done because we have taken 100 as the interval. Close. Now you can see a new layer, temporary layer of contours is generated, and this is a vector layer. These are the lines you can see. Let us change the symbology. Right click, go to properties, or the option of layer styling from here. Select the layer, click on layer styling, open layer styling, and then here change the simple line color to black, and then increase the stroke width. Say you can see the changes happening in your contour, in your display. Maybe I will decrease this a bit. I will make it 0.35, and then I would also like to want to display the label. Go to labels, select single label, and which value I want to display. You can check the attribute table. There is one ID field, two ID fields, and one elevation. Now this is the attribute contour the contour value. So there are many contours, one contour of 100, many contours of 200, 300, and so on. Highest will be, I think, 1400. So you can, yeah, you can select elevation, and then you can also change its font, make it bold, and increase the size or change the font, etc. Now you have this contour map. In fact, what you can do is, now these are the pixels. You can see one pixel is 90 by 90. What you can do is you can even add a base map and see, change the transparency level and check. Let us also do that. I will add quick map services. I will add Google Road with labels as well as Google Satellite. Yeah. And I will change the transparency level of my clipped layer. Properties, go to this transparency tab and make it 100% transparent, and 50% transparent, 50% okay approximately, and apply, so that you can see the labels in the background. Yeah, you uncheck remaining layers, you can see the background. So yeah, so this is Kadakwasla Lake. National Water Academy is somewhere here. Yeah, and there is one known location nearby Senagar Fort, which is a highest elevation, nearest elevation you see, and you can check this contours also. You see the 1300 contour. So the highest point there is above, just above 1300 meters. In this way you can check the highest overall in the whole district. The highest point is somewhere here, where you will find the 1400 contour. So that's all for this session, wherein we have seen how to do basic spatial analysis, and also we have explored zonal statistics to derive meaningful statistics from a raster layer for any polygon, and then some additional things which we have covered on contour generation. In the next session we will be doing hydroprocessing of dam and catchment delineation. See you there.